Hello everyone, welcome to analog layout tutorial. I am here to show you the process of layout of your existing design. This is the part 2 of my tutorial. Please watch the previous video, otherwise it will be a problem to understand this video because it is quite related to the previous one, as I am designing the circuit which I have designed in the part 1. So without wasting time, let's see some layout basics before proceeding to the demo. So this is the CMOS structure, standard CMOS structure. The P substrate with yellow color is backed with this black background of the layout editor. You can consider this black part as a P substrate during layout. This annual is marked with this yellow white border, this annual portion, and this is NMOS and this is PMOS. In between there is a polysilicon layer for forming the gate connection. So we have used via for it for connecting the two poly along with input connection. We have also used metal 2 here for connecting the output net. So basic things should be maintained, that is, do not overlap two same metal layer of different connection. Use different metal layer if there is chance of overlapping. For sorting two metal layer, use via. So let's move towards the demo so that it will be more clear. So this is your design as I have already shown in the previous video, CMOS inverter. So for launching the layout editor, you have to go to launch, layout Excel, create new, automatic, you keep it as it is. So this is the layout editor. So first of all, before doing layout, we have to set the grid size. Grid size means this grid size, dot to dot difference. So let's check whether grid is set or not. If it is not set, you have to give the values. So go to option, display. So grid is set now. 0.005 is the minor space, you can note it down. 0.05 is the major spacing. X snap is 0.005, Y snap is 0.005. So these are the settings you need to do earlier before invoking the layout. Okay, press OK. Go to connectivity, generate all from source. Keep only instance, press OK. You will see some black box type PCH and CH is invoked here. So press Shift F to view the layers. Here you can see this is source, this is drain, and this is gate of PMOS. This is PMOS and this is NMOS. This is source and drain. Now let us connect this. For connecting the gates, let's press O to invoke via. For invoking via, we have to press O. So M1 poly. Let's increase the number of via. Okay. Now you can sort this two gate using metal 1. So search for metal 1. Here it is metal 1 is coming. Select metal 1 DRW, drawing purpose. Press R for rectangular drawing. Click here and then click here. So I have connected the input. Gate terminal is connected now. Now let's connect the output. Click R, press R, click on the drain. Now connect it. You can use same metal layer or you can use two different metal layer, depend upon you, or it depends upon any complexity. For reducing any complexity you can use different layer. So press O, M1 M2 layer, increase the row for better connectivity. Okay, next press copy this, press C, select C, this and press C for copying the same thing if you need. Next press S to set the layer according to the via. Now use M2 to connect this output node. In layout, alignment is very much important. Keep your instance in proper alignment. Now select M1 for connecting the ground and VDD. Again VDD. Okay, now our basic connection is over. Now I have to do the body biasing of PMOS and NMOS. So for that, go to create multi-part path, press F3, annual gathering for PMOS. Next, for NMOS, go to create multi-part, F3, P sub gathering, so you take this in place below the okay. So our basic connection is over. So let us check the DRC. You can use S to align the layer. Or if any DRC arises, you have to again extend the layer also, depends upon the mirror. So this is it. Save. Now check the DRC. For DRC we have to use another tool from Mentor Graphics, that is Caliber, for layout verification. So let's invoke the Caliber. So this is it. Select the run set previous slave settings, run DRC. Here some errors are there, let us correct it. select on this here, press highlight. So let us increase to somewhat some extent. Okay. Now again check. Now on error is there. So let's select this, highlight these images, and give the layer NP layer for CMOS, give extra layer to cover the poly via, and PP layer for PMOS, this layer. Okay, save it, again run DRC. So all DRC are clean. Now let us give the pin names. So go to, let's select the layer of pin, that is this is metal 1, so select metal 1, go to create metal 1 pin. Metal 1 pin is there, you can see here, metal 1 pin, select 1, as it is, as BDD is drawn with using metal 1, so create pin, in out BDD, keep as it is same name, same, this is case sensitive, so be careful. Okay, again this is also, ground is also metal 1, so go to create pin ground GND, input output port, so this is it. Again B in also in metal 1, so go to create pin B in input, and B out is metal 2, to select metal 2, select metal 2 pin, go to create pin V out, output point pin. Okay, now I have created all the pins. Now we have to label the pins. For labeling the pins, create L, press L, sorry, BDD, select metal 1 pin, create label BDD, GND, B in. Those 3 pins are in metal 1 layer. You can select the font of your label, so press here GND, B in. Now metal 2 pin, select metal 2 pin, press L, type P out. Yeah. So this is it, our layout is over. Now our next step of verification is layout versus schematic, LVS. For that, go to caliber again, press LVS. So save it, then go to LVS. So run LVS. So LBS is not correct. What is the problem? Let's see. Oh, I think I have given wrong name, so let us correct it. So delete it. In the schematic you have to check what is the name, pin name. This is B in B out. I have given B in B out. Okay, the name is correct. So what is the problem? Let's check. B out, output port. Okay, click on that. Properties, import VN, no issues. GND is what? In output. Okay, everything is fine. Let's see. Now let's run again LBS. What's the problem? If problem persists or not, let us see. I have corrected the error, I think. So yes, LBS is correct now. So our next step is to extract the parasitics from the layout. For that, go to caliber, run packs, parasitic extraction. Capacitance and resistance is extracted so that we can simulate it using this. So run packs. So this is the caliber view setup. I have set up it to array, create all terminals, and the view will be a schematic tab view. Okay, yes, okay. So it is without any error, it is generated. Now our task is over. We have to simulate our design using the parasitic extracted view. So you can see here one new view is created, caliber view. You can open it. You can see here lots of resistance and capacitance are extracted from the layout. Pins are created, 2 MOSFETs with pins, and these are the capacitance and resistance generated from the layout. Using this view, we will simulate our test bench. So go to test bench. This will be our last step as post layout simulation, which will be called as post layout simulation. Go to test bench as created earlier. Now go to launch ADL. Go to session if you have saved state or not, load state. Actually I have saved earlier state. Okay, now go to setup environment. Here you type caliber to consider the layout view. No, to avoid schematic view, use layout view to simulate this circuit. This is the meaning. Now run it. So this is the output of layout after extracting the parasitics. Almost same output as it's a 2 transistor circuit. Less parasitics are generated. So it is up to you. If you design your layout efficiently, then less parasitics will be generated. This is a challenge to a designer, backend designer. Now you can click on that symbol. You will see caliber view on this view. Using this view we have simulated the results. So this is it. As a post layout simulation of transient, you can do a DC analysis also from this similarly by setting this environment. So this is the conclusion of part 2. Hope you like it. Thank you for watching.